Today we're going to be looking at Lab 6. So in Lab 6, when you go to page 33, Part A, the very first question says, write the balanced equations for the single replacement reactions. Okay, so what are they asking for in that question? Well, to figure that out, I want you to turn to page 29, where there is a list of the single replacement reactions for this lab. So what we're going to be doing for each of these reactions is we are going to predict the products, and then we're going to balance the reaction. And the first one is already done for you. So the first one I've written bigger so you can see it. It's 2AgNO3, so silver 1 nitrate, plus copper yields copper 2 nitrate plus silver. So, like I said, the first one's done for you, but how did they do that? How did they predict the products? How did they go through all the steps? So what I'm going to do is I'm going to erase the products here. And I'm also going to erase this 2 in front of the AgNO3. So I'm going to show you the steps that they went through to predict the products and then to balance. So for the single replacement reactions, this is the basic scheme that we have here. So we have BC, which is the compound, reacting with A, an element by itself. They're going to switch, so A is going to take the place of B, so that on the product side, A is now with C, and then B is by itself. So applying this reaction scheme to this following reaction will help us predict the product. So for B, that's silver. The C portion is this polyatomic, NO3. It's a nitrate polyatomic. And then A, on the reactant side, is just this copper. It's all by itself. So we have a compound reacting with an element by itself. And what we're going to see is that element, A, is going to take the place of B, silver. So when I go over to the product side, I want A, I want copper with the nitrate. Okay, how is that going to look though? Because the important thing when we're doing a single replacement reaction is that when we switch partners, we have new subscripts. So let me write that down. New partners equals new subscripts. So I can't just replace it and that's that. What I need to do is I need to figure out what the charge is on each of those elements or polyatomics so that when I switch them, I can see what the product's going to look like. Okay, so looking at AgNO3, how do I know the charge on those? Well, Ag is a +1. How do I know that? Well, if you look at the very bottom of page 29, it gives you all of the charges of each of the ions. Ag silver is present on there, and it's in parentheses with a plus on the outside of it, saying it has a +1 charge. The NO3 ion is also on here, and the NO3 ion has a -1 charge. Now what about copper? So when copper's by itself, it's neutral. But when I look down here at the ions, copper, when it's in an ionic compound, it's a +2. That's what this page 29 is showing me. It's giving me the charge on copper in an ionic compound. So why do I need to know the charges? Well, let's look at this. So we said over here on the product side, copper, which is this A portion, is going to pair up with C, that NO3. So what that means is I'm going to have copper with a 2+ charge, and it's going to combine with the nitrate ion, which has a -1 charge. So since the nitrate ion now has a new partner, I need to look and see what the chemical formula of that compound is going to look like. And remember, when we come up with the chemical formula of ionic compounds, our goal is to make it neutral. What that means is we need these charges to cancel. And right now we have a +2 copper and a -1 NO3. So they're not canceling. If I added those charges together, I would have an overall charge of +1, right? We have a +2 plus a -1 would give me a +1. So it's not neutral how it's written. So what I need to do is I need another nitrate ion. So to figure it out, you can use the crisscross method, where you take this number and it becomes the subscript on the nitrate ion. So you're crossing it. This number then will become a subscript on the copper ion. So what this is telling me is if I have 1 copper and 2 nitrates, then that will be a neutral compound. So my product will be Cu, and I just want one of them from that there. And then NO3, I'm going to put parentheses around it and then a 2 on the outside of the parentheses because it's saying I need 2 NO3s. So there's one of my products. What's the other product going to be? Well, it's going to be B, which is silver. And B is just by itself, so just Ag. So that is how they came up with the products for that first one. Now let's look at how they came up with the coefficients. So for the coefficient portion, what they're doing is they're balancing the equation. So when you balance an equation, you can make a list of all the elements present, and I'm going to keep the NO3 together because since it remains together on both sides of the equation, make my life easier. So looking at the reactant side, I have 1 silver, 1 nitrate, and 1 copper. On the product side, I have 1 silver, but for the nitrates, I have 2. That's what this 2 on the outside of the parenthesis means. So I have 2 nitrates. And then looking at copper, so we look at the subscript after the element to figure out how many. There is no subscript, so we assume there's just 1 copper. So we make this list so we can compare. So the silvers are balanced. The coppers are balanced, but the NO3s aren't. So I have 2 NO3s on the product side. I need 2 NO3s on the reactant side. And in order to do that, I have to add a number in front of that entire compound. So I'm going to put a 2 here because that's going to give me 2 NO3s. But it's not only affecting the nitrate ion, it's also affecting the silver. That's saying now I have 2 silvers. So now my silvers are no longer balanced. So to balance them, I'm going to go back over to the product side, adding a number in front of silver. I said I wanted 2 of them, so if I put a 2 here, that will make it 2 silvers. So that is how they balanced that equation. So what we're going to do is I'm going to go through the first few, showing you how to predict the products and how to balance the equations, and then I'll leave you to complete the rest on your own. Okay, these are the balanced equations for single replacement reactions. So on page 33, number 1, where it's asking you to write all those, it's just asking you to basically fill this in. So you can either fill this in and scan a copy to answer number 1, or you can rewrite them in this number 1 slot. Your choice. All right, so let's look now at the next one. So the next one, we have silver nitrate once again, and this time it's reacting with zinc. So same structure. We're going to see zinc take the place of silver so that zinc is with nitrate on the product side. But in order to do that, we need to know the charges because new partners mean new subscripts. So let's look at the charges. So I'm going to write each element or polyatomic with its charge. So silver is Ag, and on the bottom of page 29, it tells me that silver has a +1 charge when it's in an ionic compound. So I'm going to write Ag +1. Then nitrate is NO3, and we said it had a -1. Now, what will the charge be on zinc when it's in an ionic compound? On page 29, it has the zinc ion, and it says it's going to be a +2 when it's in an ionic compound. So I need to know this because when I switch partners, knowing the charges is what's going to determine what the formula itself looks like. So over here on the product side, I'm going to take zinc with that +2 charge, and it's going to be in a compound with NO3. Okay, we always see the positives and negatives forming ionic compounds. Okay, we're never going to see zinc +2 and silver +1 make a compound together because it's opposites that attract, like repel. So we won't see the two cations form a compound. We're going to see a cation with the anion form a compound. All right, so looking at this chemical formula, in order to change it into a chemical formula, I need it to be neutral. So I have a +2 and a -1. So the charges aren't canceling. So then I go and do my crisscross method. The crisscross method is where you take the number, not the charge, just the number, and it becomes the subscript on the opposite component. So it's saying I need 2 NO3s and 1 zinc. Okay, so that's going to become zinc, and I said I just need one of them from that number there, crossing it over, and I'm going to need 2 NO3s, just like up here. So I want to do parentheses with my nitrate ion inside the parentheses, and since I need 2 of them, I'm going to put the 2 outside, saying I need 2 NO3s. Now, for the other product, it's going to be the silver all by itself, what we kicked out. Now to balance, it's going to be the same as before, excuse me. So looking, I have 1 silver, 1 silver. NO3, I just have 1 of the NO3s. But over here, because of that subscript 2, that means I have 2 NO3s, so they're not balanced. I need 2 on the reactant side, so I'm going to add a 2 coefficient here. That's changing my silvers to 2 as well, so I want to put a 2 over here to make sure that I have the same amount of silvers on both sides. So 1 zinc, 2 NO3s, 2 NO3s, 2 AGs, 2 AGs, balanced. So this would be the balanced chemical reaction for that one. Let's move on. So the next one, we're taking silver nitrate once again, and this time adding lead. So the first step, write down the atoms or polyatomics with the charges so that when we switch them, we'll know how to come up with the correct chemical formula. So we have same thing, silver with a +1, NO3 is a -1, and then lead, looking at the page, it tells us the lead that we're using is lead 2. So lead with a 2+ charge. So lead is going to pair up with the anion, the nitrate ion here, of that compound. So we're going to see lead with a 2+ charge pairing up with the NO3. Since the charges don't cancel, we do the crisscross method, and that tells us that we're going to need 2 NO3s and 1 lead. So we have PB1 NO3 sub 2. So that's one product. The other product is going to be the silver. And you can go through and write the list to balance, but to balance it, you would just need a 2 here and a 2 here because it's very similar to the previous ones. All right, and I did want to point out, so whenever you see, so looking at this next example here, we have copper 2 nitrate reacting with copper. Okay, so notice, single replacement reaction, we're taking the same cation and switching it. What I mean by that is the reactant side is going to be exactly the same as the product side. Not changing at all, because switching copper with copper. So when you do a reaction like this, you don't actually need to balance those ones or anything, and you can cross it out because we're not going to see a reaction, NR. There will be no reaction here because copper replacing copper, nothing's happening. It's staying the same. The reactants are the same as the product, so there was no reaction. So what I want you to do is go through and complete the rest. So you have copper 2 nitrate with zinc. So write the charges, switch partners, figure out what your new products are going to look like and balance. You have copper 2 nitrate with lead, so you'll do that one as well. And then lead 2 nitrate with copper, the PbNO3 sub 2 plus Cu. And then the lead 2 nitrate with zinc. That very last one, you're switching lead with lead, so you can cross that one out. Okay, now you'll notice there's a box at the bottom here. I'm going to go ahead and erase this so I can show you what I'm talking about. It's kind of hard to see on the paper, so let me make it a little bit bigger. Now this box, it's like 9 checks. This is what you're going to use along with the PowerPoint video to record if a reaction happened. So, how do you do that? Well, on the PowerPoint slides, and this is a separate video, you're going to see that I'm going to be showing each of these reactions, either a video or with pictures. So this very first box, what this very first box is saying is if I took copper and reacted it with silver nitrate. Okay, so it's saying this reaction here, AgNO3 plus copper. Okay, and you should have already had this balanced chemical equation on your sheet. It's one of these single replacement reactions. So they're saying when these two were reacted, did something happen? So you're going to go to the video, you're going to watch the mixture of copper with silver nitrate, and if you see a color change, if you see bubbles, if you see the solid dissolving, anything like that, then yes, a reaction happened. So all you would do is if a reaction happened, you would put an X saying yes. If a reaction didn't happen, for example, this next box here, we have copper with copper nitrate. Okay, let's look at that. Copper plus copper nitrate. Well, remember I said copper's switching places with copper, so nothing's actually changing. The reactants and products are the same. So if you mix these two together, you're not going to see a reaction. So this would be NR, no reaction. Copper with copper nitrate, no, nothing happens. So the same could be said over here. So notice I have a lead, so this is a solid lead metal, reacting with lead to nitrate. So we're looking at this box here. We're saying we have lead with lead nitrate. Well, lead switching places with lead. That means the reactants and products are exactly the same, so no actual reaction is happening. So this would be an NR as well. To figure out the rest of these, refer to the PowerPoint video. I will have each heading with the reactants in the heading so that you know exactly what reaction you're looking at. If a reaction happens, you'd put an X there. If a reaction doesn't happen, you would write NR. And then you'll be using this to answer the rest of the questions for experiment 6. Now let's look at the double replacement reactions. So there's another set of reactions for this lab, and that is where we are taking two compounds and reacting them together, and they're switching partners. So for a double replacement reaction, this is the basic layout. So the main change here is instead of reacting a compound with an element by itself, we're actually reacting two compounds together, and they switch partners. So the very first example you have on page 30 is PbNO3 sub 2 plus AgNO3. So you need to predict the products is the first step. And we predict the products much like we did for the single replacement reactions. We're going to be writing all the elements and polyatomics with their charges and then switching. Now for this first one, we have lead, it's a 2+ charge. And then we have NO3 with a -1 charge. And remember, all of these ions, all of these charges I am getting from at the bottom of page 29. That's where I'm getting those charges from. Now, silver, Ag, it's a +1. and then NO3 is a -1. So when we switch partners, what's going to happen is the cation, so the positively charged ion, is going to switch with the other positively charged ion. So they're switching places. Now notice for this particular one, the anion portion, the negative ion, is NO3 in both cases. So when they switch partners, since the anion, the negative portion, is the same, the products are going to be exactly the same as the reactants. So reacting lead 2 nitrate with silver nitrate gives you lead 2 nitrate and silver nitrate. And remember what I said about reactions that have the same reactants and products. If you mix them together, there is no reaction. Nothing actually happens because the reactants and products are the same. So this would be an NR, no reaction. And you can even fill that in on your table on page 31. So in your table on page 31, the one we just looked at, is where we took AgNO3, silver nitrate, and lead 2 nitrate. So this second box here, so that would be an NR, no reaction. All right, let's look at another one that might possibly be a reaction. So the key for double replacement reactions, how do you tell if a reaction's happening? Well, when you watch the PowerPoint video and you see the two solutions mixed together, evidence of a chemical reaction for double replacement reactions is oftentimes color change, but the formation of a solid is the big one. So if you see a solid form, if it gets cloudy, that means yes, a reaction happened. You can also predict if the reaction is going to happen by predicting the products. So what do I mean by that? Well, let's go same way we did up here. Start by writing each element or ion with its charge. So we have a lead +2 and then NO3 -1. Notice I'm just writing the ions and charges. I'm not worried about this subscript of 2 out here. That's just saying there are 2 NO3- ions. Okay, but I don't need to include that anywhere in here when I'm writing just the charges. Now K is potassium, and potassium is a +1 charge. CrO4, that's a polyatomic, and it has a -2 charge. And I want to point this out on your sheet. Page 29 at the bottom, you have CrO4, and then it says that it's a +2 ion. That's wrong. It's -2. Okay, so that's a typo on your lab manual. So it's a -2 charge. So I'm writing all of these charges so that when I switch partners, I can predict what the chemical formulas are going to look like. So the cations, the ones with the positive charge, these are going to switch partners. So what that means is potassium is going to pair up with NO3, and lead, Pb, is going to pair up with CrO4. So let's see how that looks. We just said potassium with its +1 charge is going to pair up with NO3, which has a -1 charge. Now the nice thing about this, look, +1, -1. Charges cancel. So I don't have to do the crisscross method. Because if the charges cancel, that means I just need one of each of those for it to be neutral. So my product is going to be, one of my products is going to be KNO3. Now what's my other product going to look like? Well, I said I'm going to take lead, and it's the cation always comes first, so we always write the positive charged ion first. Lead with a +2 charge is going to pair up with CrO4, and that has a -2 charge. And look, once again, +2, -2, charges cancel. So I don't need to do the crisscross method. That just means that I only need one of each of those. So one lead and then one CrO4. So that is what my chemical formula is going to look like for lead 2 chromate. All right, so once I have my products, we also need to balance. So let's look at how balancing this equation is going to be. Remember, you're trying to get the same amount and types of atoms on both sides of the equation. So I have 1 lead, because remember, we look at the subscripts, and that tells us how many we have of each. So 1 lead. Over here I have 1 lead as well. Looking at the NO3 ions, on the reactant side, I have 2 of them. So on the product side, I only have 1. How do I know it's just 1? Imagine parentheses around that ion. Outside of the parentheses, there is no number, so we assume there's just 1 of them. So 1 NO3 on the product side, 2 NO3s on the reactant side. So I need 2 on both sides, so I add a coefficient of 2 in front of this compound. That tells me I now have 2 NO3s, but it also changed my potassium. Now I have 2 potassiums as well. But that's okay, because look, I have 2 potassiums on the reactant side, so it balanced itself out. So this would be the balanced chemical equation reacting lead-2 nitrate with potassium chromate. Now, how do I know if a solid formed or not? We're going to be looking at your chemical reactions on the PowerPoint video to see if a solid did form. You could also use your solubility chart. So looking at the solubility chart, what the solubility chart has are positive ions along the X, and then negative, or along the Y, sorry, and then negatives along the X. So I'm looking at just my products. And remember, we said the products had K plus and NO3 pairing up, and then lead 2 plus and the chromate pairing up. So these are the ions that you can find on this chart. So for this first compound here, I'm going to find K plus, and it's the second to the last one down, and it's paired up with NO3, and the NO3 is this guy here. So you're following them and seeing where they meet. So potassium, K plus, meeting up with NO3 minus, and there's an S in that spot. What that S means is that this compound is soluble, meaning it dissolves in water. It does not form a solid. So not a solid. So if you see an S, that means it's not a solid. I know it's counterintuitive. You see an S and you might think, oh, solid. No, it means soluble, meaning it dissolves in water. So this will not form a solid. Now let's look at the other compound we made. We have CrO4 with lead. So lead is the very last ion on the positive ion side, and then CrO4 is the middle negative ion. So falling lead over to where CrO4 is, now we have an I. And what I means is insoluble. So this means that lead 2 chromate will form a solid. So solid is formed. So when you watch this reaction, or when you see the pictures for this reaction, you're going to see a cloudiness, and that cloudiness is the lead 2 chromate forming. That's solid forming. Okay, so a reaction did occur with this one. So this is part B of the experiments. Using the solubility table, you'll also be able to answer some of the part B questions there. All right. So I'll go ahead and do one more. Moving right down the line, I'm going to do the lead 2 nitrate with barium chloride. So we're going to go ahead and predict the products of this guy. So you want to write the charges, and these I get from the page 29, and then Cl-1. Remember, we're switching partners, so we're going to have the two cations switch places. So barium's going to take the place of lead, so it's now with the nitrate ion. So we're going to get barium with a 2+ is going to pair up with the NO3. So notice charges are not canceling this time. So I do my crisscross method, telling me I need 2 NO3s and 1 barium. So Ba, just one of them, and then NO3, since there's more than one, I'm going to put parentheses around the entire polyatomic, and I'm going to put a 2 on the outside of the parentheses. Now what's left over is this lead 2+ and the chlorine, so those are going to pair up. Notice those charges are not canceling, so I'm going to take and do the crisscross method. This tells me I need 2 chlorines and 1 lead. So Pb, just 1, and then Cl2. Now this is actually already balanced, and you can write a list and prove that to yourself if you wish to do so. So no alternations need to be made. It is already balanced. But what I want to look at is practicing again with that solubilities chart. So when you use the solubility chart, what you're using it for is to predict if either of these products formed a solid. Because if it did, then a reaction happened. So looking at it, this first compound has the NO3- ion and the barium 2+. So I find barium 2+, that positive ion on the solubility chart on page 28. And I'm going to follow that over all the way to the NO3- column. So when barium 2+ pairs with NO3-, there's an S. And an S means that it's soluble. So no solid formed here. Okay, so this is not a solid, it's aqueous. What about the lead 2 chloride? So lead 2+ is the very last positive ion on the table. Chlorine is the first negative ion, that first column there. So when lead 2+ combines with chlorine, there's an I. And what an I means is insoluble. So that means yes, a solid formed. So this did form a solid. So a reaction did happen. And you'll see that in the video as well. So go through and starting with that lead 2 nitrate reacting with copper 2 nitrate. For that one, notice that you have the same anion on both sides. So when I say the same anion, you have lead NO3 reacting with copper NO3. So when they switch partners, it's going to look exactly the same since that NO3 is the same on both. So no reactions happening here, so you don't even need to do that one. So when the anion portion is the same, no reactions happening.